The rainfall of our country is dependent on the monsoons. Rainfall controls our agriculture, but the agriculture of our country is said to be the gambling of the monsoon, as the monsoon rainfalls are uncertain, irregular and uneven or unequal. So, irrigation is essential for agriculture. About 80% of the total annual rainfall of India occurs during these 4 months, that is from mid-June to mid-October. So, it is essential to provide irrigation for production of crops etc. during the rest of the 8 months. The monsoons are uncertain, so irrigation is necessary to protect crops from drought as a result of uncertain rainfall. It does not rain equally in all parts of the country, so irrigation is necessary for agriculture in less rainfall areas. Soils of some areas are sandy and therefore porous, for which a major portion of rainwater sinks down very quickly. So, sandy soils cannot retain water like the alluvial soil and the block soil. That is why irrigation is essential for farming in the areas having sandy and loamy soils. The rainwater flows down very quickly along the slopes of hillsides. So, irrigation is necessary to grow crops in such areas. Irrigation systems. Water is an important constituent of the plant body. Plants need water to carry on different physiological processes essential to their growth and development. A great deal of water from plant body is wasted through the process of transpiration. Therefore, to compensate this loss of water, absorption of water from soil is an important phenomenon. Soil gets water mainly from 2 sources, namely precipitation and irrigation. Irrigation is a process other than natural precipitation which supplies water to crops, orchards, grass or any other cultivated plants. In the wetter parts of the world where rainfed cultivation is practiced, the farmers' activities consist of selecting suitable land, preparing the land for cultivation, sowing, tending and harvesting the crops. Natural rainfall provides the water needed, but in many other places otherwise favorable for cultivation, natural rainfall does not provide all the water needed, and as such irrigation of crops is required to make up this deficiency. Techniques adopted for carrying water from its source to the crop are called methods or modes of application. The flooding, wetting the entire land surface, furrows, wetting only certain parts of ground level, sprinkler, in which the soil is wetted in much the same way as rains, subsurface irrigation, in which surface is wetted very lightly but the subsoil is fully saturated, localized irrigation, in which water is applied at each individual plant at a near daily rate. The factors influencing irrigation. An efficient method of irrigation should fulfill 5 major objectives, namely the distribution of water uniformly over the field according to crop need, storage of maximum fraction of water in the root zone for plant use, crop growth should not be adversely affected, soil transport or loss is negligible, the technique used is economically sound and adaptable at the farm. The selection of a suitable irrigation method for a particular farm location depends upon the factors such as soil, water, crops, etc. The soil, textural, crusting, cracking and infiltration are the characteristics of surface soil. Nature and depth of relatively watertight layers in subsoil if any, water storage capacity of root zone, nature and extent of land slope, size of field, surface drainage, nature and extent of salts in surface and subsoil are the salient soil factors influencing between of an irrigation method. The water, nature of water supply, size of water delivery, quality of irrigation water and quantity of water supply are a few factors that must be taken into consideration while deciding the method of irrigation. Crops, nature of crops, area under different crops and their rooting behavior, optimum depth and timing of irrigation, sensitivity of crops to excessive soil moisture, cultural operations required, etc. must be considered at the time of selection of irrigation method for a crop. These are other factors influencing irrigation method like outlook, managerial efficiency and financial resources of the farmer, nature of the farm machinery used, availability and cost of labor, wear and tear maintenance facilities and cost of irrigation equipments and availability of power supply. As far as possible, an irrigation method should not only provide a high level of water application efficiency, but also ensure its economic viability, sustained soil productivity and wide adaptability to prevalent feature of the farm. Generally, irrigation methods followed in India lack an economic use of irrigation water. Methods of irrigation, surface irrigation. In this method, water from an irrigation channel is allowed to reach a part or whole of the field and spread by the gravitational flow incidental to the slope of the land. Water may be distributed to the crops in border strips, check basins or furrows. The important requirements to obtain high efficiency in surface methods are properly constructed water distribution system to provide adequate flow of water to the fields and proper grading and leveling of land to achieve uniform distribution of water. The advantages of this method include, since in this method the entire area is not flooded, it ensures high water use efficiency. Excessive seepage loss can be avoided by adopting this practice. Damage to plants and loss of soil nutrients do not occur in this practice. The major disadvantage of check basin method of irrigation is that the ridges interfere with the movement of animal drawn or tractor drawn implements for intercultural operations and harvesting of crops. Considerable land is occupied by ridges and lateral field channels and crop yields are substantially reduced. The method impedes surface drainage. Precise land grading and shaping are required for this method of irrigation. Furrow irrigation. The furrow method of irrigation is used in irrigation of row crops where furrows are developed in between the crop rows in the planting and cultivating processes. The size and shape of the furrow depends on the crop grown, equipment used and spacing between crop rows. Water is applied by running small streams in furrows between the crop rows. Water infiltrates into the soil and spreads laterally to irrigate the areas between the furrows. Time taken by water to flow in the furrow depends on the amount of water required to replenish root zone and the infiltration rate of the soil. Both large and small irrigation streams can be used by adjusting the number of furrows irrigated at any one time to suit the available flow. In areas where surface drainage is necessary, the furrows can be used to dispose of the runoff from rainfall rapidly. The advantages of this method include water in the furrows contacts only 1/2 to the 1/5 of the land surface, thereby reducing puddling and crusting of the soil and evaporation losses. Yearly sowing is possible, which is a distinct advantage in heavy soils. It can be safely adopted on the slopy lands by opening the furrows across the slope. The disadvantage of this method include it requires skilled laborers to operate. It may cause serious erosion if excess water flows over the ridges, and it is difficult to carry on mechanical operations. Irrigation furrows may be classified into two general types: is based on their alignment. They are straight furrows and contour furrows. Based on their size and spacing, furrows may be classified as deep furrows and corrugation. Straight furrows like borders are laid down across the prevailing land slope. They are best suited to sites where the land slope does not exceed 0.75%. Contour furrow method is similar to the graded furrow method in that the irrigation water is applied in furrows, but the furrows carry water across the sloping field rather than down the slope. Contour furrows are curved to fit the topography of the land. Now let us see about subsurface irrigation. In this method of irrigation, water is applied below the ground surface by maintaining an artificial water table at some depth depending upon the soil texture and the depth of the plant roots. Water reaches the plant roots through capillary action. Water may be introduced through open ditches or underground pipelines such as tile drains or mole drains. The depth of open ditches varies from 30 to 100 centimeter and they are spaced about 15 to 30 meters apart. This water application system consists of field supply channels, ditches or trenches and drainage ditches for the disposal of excess water. The irrigation ditches should be suitably spaced to cover the whole field adequately. This method is suited to soils having reasonably uniform texture and is permeable enough for water to move rapidly both vertically as well as horizontally within and for some distance below the crop root zone. The soil profile must control a barrier against excessive loss through deep percolation. Topography must be smooth and nearly level or slight slope, very gentle or uniform. Advantages of subsurface irrigation. In soils having low water capacity and a high infiltration rates, where surface methods cannot be used and sprinkler system is very expensive, subsurface irrigation method can be used effectively. Evaporation loss from ground surface is minimum. In this method, it is possible to maintain the water level at optimum depths for crops required at different growth stages. The disadvantages of this method include it is quite expensive and labor intensive in the beginning. The method requires an unusual combination of natural conditions, therefore its scope is limited. Frequent removal of accumulated soil and other materials from channels is necessary. In India, this irrigation is practiced to a limited extent for growing vegetable crops around Dal Lake in Kashmir and for irrigation of coconut palms in the organic soils of Kuttanad area in Kerala. Sprinkler irrigation. In the sprinkler method of irrigation, water is applied above the ground surface as spray. The spray is developed by little flow of water under pressure through small orifices or nozzles. The pressure is obtained by pumping with careful selection of nozzle sizes, operating pressures and sprinkler spacing. High efficiency in water application or distribution can be obtained with the sprinkler system. Sprinkler systems are of generally two major types, namely rotating head system and perforated pipe system. In case of rotating head system, small nozzles are placed on riser pipes and these riser pipes are fixed at an even interval along the length of lateral pipes which are placed on the ground surface. However, they can be mounted on posts exceeding the crop height and made rotating through 90 degree. In rotating sprinkler, the most important device to rotate the sprinkler head is a small hammer activated by the thrust of water striking the vane connected to it. In case of perforated pipe system, holes are perforated in lateral irrigation pipes which are especially designed to distribute water with a good deal of uniformity. This system is usually designed for low operating pressures, that is 0.5 to 2.5 kg per square centimeter. Due to this low pressure, the system is attached to an overhead tank to achieve the requisite pressure head. The sprays are directed on both sides of the pipe, which cover a strip of land from 6 to 15 meters wide. Nearly all cultivable soils can be sprinkler irrigated. It is however not suitable in very high textured soil where the infiltration rates are very low, that is less than 4 mm per hour. Most crops excepting rice and jute can be sprinkler irrigated. The flexibility of sprinkler equipment and efficient control of its application make this method adaptable to most of the topographic conditions. However, extremely high temperature and wind velocity markedly reduce the uniformity of water distribution and irrigation efficiency. This system of irrigation is especially useful to the soils that have steep slopes or irregular topography and soils which are too shallow to level. Advantages of this method include that this technique enables judicious utilization of even small water flows and permits efficient irrigation of undulated lands and soils with shallow depths. It saves 10 to 16% land that is used in construction of channels and ridges in other methods. Highly permeable as well as relatively less permeable soils can be easily irrigated by sprinkler method without any risk of runoff and erosion, inundation and seepage losses. Fertilizers, pesticides and weedicides can be applied along with the water spray, thus saving extra labor. Disadvantages of this method include high initial cost of equipments. Operating costs are generally higher than irrigation by surface methods. Winds disturb the sprinkler pattern, giving uneven distribution of the irrigation water. Drip irrigation. As the name signifies, drip irrigation, also termed as trickle irrigation, which involves the slow application of water to the root zone of a crop. The method was initiated in Israel and is now being tried in other countries. In this method, water can be used very economically since loss due to deep percolation and surface evaporation are reduced to the minimum. This method therefore is highly suitable to arid regions and orchard crops. The successful raising of orchards even on saline soils has been made possible by the drip system of irrigation. The system can also be used for applying fertilizers in solutions. In this system, water is applied more frequently close to the stems of plants through suitably spaced drippers, that is emitters, attached to plastic or metallic pipes spread above or below soil along crop rows. The pipes are hooked to source of water supply through a storage tank or pressure device which provides necessary hydraulic head or pressure for movement of water to the drippers. A pumping unit creates a pressure of about 2.5 kg per square centimeter. In this case, only a part of soil in the vicinity of roots is wetted and kept close to field capacity. Earthen pot irrigation. This method has been recently developed by the Haryana Agriculture University, Hisar. It is very cheap and convenient method and can be easily adopted. In this method, first a pit of 60 cm deep and 90 cm wide is dug out and the earthen pot is embedded up to the neck level and then it is filled with water. The water is absorbed by the soil through capillary action. One pot is sufficient to moisten 1 square meter area. This system is especially useful for irrigating vegetable crops like cucurbitaceous vegetables grown in sandy loam or sandy soils. Advantages of this method include it is the most suitable method for vegetable and orchard crops where plants are widely spaced. Secondly, saline water can be freely used because salts are deposited at the bottom of the pot and high water use efficiency will be there, and a double walled pot called Jal Tripthi can also be used. It is a useful irrigation device for the desert developed by the Central Arid Zone Research Institute Regional Station, Bikaner. It reduces the frequency and total amount of water needed and ensures a regulated constant supply of moisture to tree plants for survival and better growth. This device consists of a double-walled earthen pot called Jal Tripti. In English, it is meant as water satisfaction. The diameter of the outer pot is kept approximately 25 cm at the top, and at base it is 18 cm. The diameter of inner pot is 15 cm on top and 12 cm at base. The height is kept 30 cm. Since it is prepared on potter's wheel, approximate dimensions have been given. Moreover, some variations in the measurements may occur. The dimensions of the inner pot have been kept slightly bigger than the size of the polythene bags, that is 25 cm long, measuring 10 cm across, which is used for raising plants in nursery. Both the pots are joined together at the base, and the basal portion of inner pots is kept almost open. The external side of the outer pot is made impervious with the help of paint, cement or coal tar. Tuboponics. The tuboponics is a fairly recent development in the field of irrigation. This technique has been developed in Israel and practiced in the desert areas of that country in order to convert it into green lush forest. In tuboponics, water is provided to plants or trees through injections. The needle is inserted into the plant stem and water is delivered into the phloem. The needle and injection used for this purpose are of special shape and design prepared only for this purpose. In India, this technique has not yet arrived, but it may prove very useful in Indian deserts where water is very scarce. Its use in crop plants seems to be impracticable. It is a very simple device. Adverse effect of improper irrigation. As water is a limited source with no substitute, its efficient and judicious utilization is of utmost importance in sustaining and increasing agricultural production. If irrigational water is used inefficiently and unscientifically, it may cause certain adverse effects rather than being useful to the crop and soil. Seepage from main and branch canals, distributaries and field channels, along with the deep drainage loss from the base and cropped fields due to heavy rains and over irrigation, add to the groundwater and cause rise of water table. If not checked, the water table may rise close to the surface and cause waterlogging of soil. If there is a salty layer in the soil, the salts may get dissolved in the rising water table and come up on the surface soil, thereby rendering the soil less productive due to salinity. Soil aeration is also badly affected. Rising of water table beyond the threshold depth can be prevented by providing requisite subsurface drainage. Alternatively, in areas with good quality groundwater, radial drainage with shallow pumps and recycling the water for irrigation can be practiced with advantage to keep down the water tables and stretch the irrigation supplies. Another aspect associated with injudicious irrigation is leaching of the mobile nutrients like nitrates below the root zone of crops, which decreases the nutrient use efficiency by crops. In order to minimize this loss through leaching, it becomes necessary to regulate irrigation and fertilizer applications. Cultural practices to increase water use efficiency in India. Water has become a precious commodity in modern agriculture. Therefore, adoption of certain practices is greatly beneficial in judicious harnessing of available water resources. Tillage. The tillage operations have a great bearing on irrigational requirements of the crops through their effect on subsurface water storage and utilization by crops. Tillage increases infiltration rate, reduces evaporation and enhances penetration of roots into deeper layers. With an increased infiltration, higher water storage in the root zone of soil becomes possible. Greater availability of soil decreases due to the need of supplemental irrigation. Tillage for seed bud preparation opens up soil and increases evaporation from the tilled layer, but at the same time it also breaks the continuity of upward flow of water, that is capillary water, from the moist layers below, and as such reduces water loss through evaporation. Land grading. It is an essential process for bringing about uniform distribution of irrigation water, especially in surface irrigation, on undulating and sloping lands. It minimizes the danger of flooding of low lying areas and under irrigation of raised locations. Fertilizer use. Recent studies have proved that fertilization of crops enhances water use efficiency. Besides, fertilization promotes deeper and more profuse root system, which extracts more water stored in deeper layers of soil. Care should be taken not to use high doses of fertilizer where water supplies are limited. Cropping patterns. Much attention has not been paid towards the development of appropriate cropping patterns which can suit the irrigation supplies available at the farm. The usual tendency is to match irrigation needs to crops on considerations other than availability of water. The role of crop planning is in respect of efficient use of water has not been well recognized. Then mulching. Mulching is the practice of spreading an extraneous material on surface of soil to increase water retention, check evaporation, reduce soil erosion, improve edaphic environment and suppress weeds. Various types of mulches, namely paper polythene film, crop residues, petroleum products, etc. have been used to realize these objectives, but unavailability and high costs of most of these materials discourage their large scale use as mulch. In those regions where paddy straw and wheat straw are available in plenty, they can be used for mulching. Straw mulching in crops sown during hot and dry summer has been found to increase crop yields and economize irrigation water and fertilizer use. Therefore, it can be an important practical aid in improving water use efficiency of crops. Then coming to weed control. As weed compete with the crops for light, water and nutrients, their development along with the crop growth enhances rate of soil water depletion. Further, weeds obstruct the movements of water in the irrigation channels and fields and thus promote percolation loss. These weed induced effects necessitate more frequent watering. The adverse effect of weed on soil water use is more pronounced during early stages of growth when the crop cover is sparse and weeds significantly contribute to canopy and hence evapotranspiration loss is high. Thus, an efficient weed control in the irrigation channels as well as in fallow or and cropped fields through mechanical operations and weedicides are essential to economize farm irrigation supplies and to increase water utilization efficiency for crop production. Irrigation scheduling. In irrigated areas, optimum irrigation scheduling to crops constitute a major cultural practice because it is one of the most important factors governing the yields of crops. Besides, irrigation scheduling has profound influence not only on the efficient management of an individual farmer's irrigation supplies, but also on judicious planning in relation to canal command development and optimal allocation of water resources among crops and regions. A farmer can easily adopt an optimum irrigation schedule provided it is simple and economical. Conclusion. We have discussed about irrigation, factors affecting suitability of irrigation method, methods of irrigation and adverse effect of improper irrigation in mulberry cultivation. We have also discussed about cultural practices to increase water use efficiency in India, especially for mulberry cultivation. To summarize, water, though precious, is one of the scarce resources required for food grain production in our country. Every care should be taken to utilize this resource efficiently. Selection of an appropriate method of irrigation based on crop and soil type is a prerequisite for efficient utilization of water. It also helps in enhancing and sustaining soil productivity in the long run. Various methods of irrigation have been comprehensively discussed in this lesson. Characters of an efficient method of irrigation, factors affecting the suitability of an irrigation method, and cultural practices for increasing water use efficiency have also been briefly highlighted.